All right, guys, here we are, last video of the chapter. Can you believe we made it through all of the graphs? So we've done sine and cosine, we did secant and cosecant, and those are so similar to sine and cosine. So now we have tangent and cotangent, which are a totally different ball game. So these have a whole different set of rules, you guys. So kind of separate tan and cotan from what we've been doing already. And I'm going to give you some new strategies and some different things to think about. But what I want to do is first remind you of unit circle stuff. So remember tangent of 0. That means 0 degrees, y over x. The y value is 0 at 0 degrees, so that means tan of 0 is 0. And notice how that gives us a point right here. Okay, these are not things that you have to memorize brand new. These are things you already have memorized. How about pi over 2? So remember where pi over 2 is? That's 90 degrees. The y value is 1, but the x value is 0. That's undefined. That's weird. Notice how we have an asymptote there. Asymptotes mean undefined, okay? And then the tangent function looks different than sine and cosine, secant and cosecant. Remember how tangent can be anything? And so that means it goes down to negative infinity and up to positive infinity, but we have all these asymptotes on the x-axis here. So just keep that in mind. The other weird thing about this, which I'll explain more in a second, is that what's the period for this graph? Beginning to end? So the difference between pi over 2 and negative pi over 2, that's just 1 pi. So period is different for tangent. Period is regular pi, not 2 pi like the other ones we've been doing. Let's talk about cotangent for a second. So remember that cotangent is x over y. So at 0 degrees, the x value is 1, but the y value is 0, so that's undefined. So notice how at 0, there's a dotted line. Same thing for pi. That's different than the tangent function. Okay, the other thing is that at pi, remember the x value at pi is -1, and the y value at pi is 0, so -1 over 0 is undefined. So again, we have our asymptote there. What about pi over 2? So cotangent of pi over 2, the x value at pi over 2 is 0, the y value is 1, 0 divided by anything is 0, that's where our point is, 0 pi over 2. So these are unit circle problems, you guys. These are unit circle questions. That's why we spent so much time memorizing them, is so that you wouldn't have to continue to re-memorize stuff throughout the rest of the semester. Other thing I want you to keep in mind is that this one is a tangent graph, and notice how it goes from down to up. That's an increasing function. Remember what we had you memorize was that tangent, as theta increases, the tangent also increases. This is an increasing function. So on the flip side, we have cotangent. It's the opposite. Cotangent is a decreasing function. That means from left to right, it's going down. Okay, that's another reason, way to remember the difference between the two. Okay, so those are just some thoughts for you. Go ahead, turn the page. I have some notes for you to write down, and then I will do the next two examples. So go ahead, pause the video and copy these notes down if you would like, if I'm going too fast. But here's some main differences. The period is just pi over b. Remember, all the other ones we've done were 2 pi over b. The b value is the same. It's still the number in between tangent or cotangent and the x. The b is still the same b that we've been using, but we use pi over b for the period, not 2 pi over b here. And here's the other thing that's pretty important, is that to write the equations of the asymptotes, it depends on if it's a tangent function or if it is a cotangent function. So these are the formulas that you're going to use to figure out the asymptotes. Whatever your b value is, do b times x equals negative pi over 2 and positive pi over 2 for tangent, and that's because the tangent is undefined at pi over 2 and negative pi over 2. Remember here, the asymptotes for tangent are at negative pi over 2 and pi over 2, and that's where these come from. Okay, and that's affected by the b value, but the same thing for the cotangent graphs. I'll highlight those in a different color. Those, for the asymptotes, you're doing bx, whatever the b is, equals 0 and equals pi. And that's because that's where those are undefined for cotangent. Okay, so those you already have memorized, but you're going to have to think about it in terms of writing the equation of the asymptotes. The other two things are the midpoint of the asymptotes, whatever is halfway in between the asymptotes. So here's one, here's the other. Your point goes in the middle. Here's one asymptote, here's the other one. Directly in the middle is the point for the graph. And then the tangent of x is an increasing function. The cotangent of x is a decreasing function. So these are the shapes. And then just remember the curve approaches the asymptotes, just like for the secant and the cosecant graphs, okay? So very first problem, here's how I'm going to start. For y equals tangent of 2x, that means my b is 2. So to figure out the period, instead of 2 pi over b, for tangent I'm just doing pi over b, which is pi over 2. That is the period. And then the equation of the asymptotes, what I'm supposed to do is bx equals negative pi over 2 and bx equals positive pi over 2. Okay, so what was the b again? It was 2. So I'm actually going to write a 2 here. I'm going to write 2x equals negative pi over 2, and I'm going to do 2x equals positive pi over 2. How do you divide both sides by 2 here? Again, we have fractions coming into play. Dividing by 2 is the same thing as multiplying by 1/2. That means one of my asymptotes is at negative pi over 4. The other asymptote is at positive pi over 4. What's half of a half? A fourth. Okay, so what I'm going to do here is I'm going to put a tick mark for my first asymptote at negative pi over 4. I'm going to put a tick mark here for my second asymptote at positive pi over 4, and those are my dotted lines. Here we go. And the midpoint of that is where my point goes. So I'm going to put a point right here. And the tangent graph is increasing. So what that means is it starts down here and it goes up like so. And how do I figure out what my other 2 points are? So I haven't talked much about amplitude yet, but there's just a 1 in front of here, which kind of explains the humpiness again. So I'm going to put y value labels of 1 and negative 1. The problem down here is going to be 3 and negative 3, just in case you were curious. But I'm going to put 1 and negative 1, and let's label our graph a little bit better. What's halfway in between 1/4 and 0? It's 1/8. And this is positive pi over 8. Okay? So those are my other 2 points that I'm going to connect. So it's just a midpoint. What you could do is take negative 1/4 and divide it by 2, just like we did this. That just doubles the bottom number. Okay, so that's where my other 2 points are going to come from. I have negative 1 comma and negative 1/8. That's just from doing the midpoint, because I know I have symmetry going on here. Okay, and my graph approaches the asymptotes, has a little kink in the middle, and done. Okay, now let's do this last one. My b value is 1/2. This kind of affects the amplitude, although it's not really a humpiness. Notice how it goes down forever and up forever. So tangent and cotangent actually don't have amplitudes, but that negative 3 does affect the y value somehow. It's just not called an amplitude because an amplitude represents a distance and the tan goes forever up and down. So I'll get to that in a second. Let's figure out the period. It's pi over b, which is pi over 1/2, which is 2 pi. Flip and multiply. So that's my period for this case. That means distance from one asymptote to the other asymptote is 2 pi. For this problem up here, since my period was pi over 2, that means the distance from this asymptote to this asymptote is pi over 2, and it is. Okay, just to review that. That means 2 pi. Let's do my asymptotes. For tangent, I'm doing bx equals negative pi over 2 and bx equals positive pi over 2. This is just like the formula that you start with, and that's, remember, because the tangent is undefined at negative pi over 2 and pi over 2. For cotangent, it's different. You have those written in your notes above. But remember, the b is 1/2, so I'm going to put a 1/2 here and here. So that means 1/2 x equals negative pi over 2, and 1/2 x equals positive pi over 2. Well, the 1/2s cancel. I have a 1/2 on each side, basically. So I have x equals negative pi and x equals pi. That's where my asymptotes go. Negative pi and pi. Okay, so put my dotted lines there. I'm getting a little bit messy because I have drawn a lot of scratch work here, but that's okay. My point goes right here in the middle. And remember, I have like this multiplier in front, which isn't referred to as the amplitude for tangent graphs, but that does affect my y value. So I'm going to go 3 and negative 3. All right. And did you notice that this is a negative? What does a negative do? Flips it upside down. So this is actually going to look like a cotangent graph, even though it is negative 3 tangent. Okay, so beware of that. It's flipped upside down, so it's going to actually look decreasing. And let's label 2 more x-axis values. What's halfway between 0 and negative 1? 1/2. So I'm going to put negative pi over 2 here and pi over 2 there. And that's where I'm going to connect my points. I'm starting up at positive 3 here, again, because the negative tangent graph is actually decreasing. And then at pi over 2, I'm at negative 3. And here, little kink in the middle. There we go. Okay, so that's how to do tangent, you guys. Cotangent is very similar, except it's just decreasing instead of increasing. I'm going to do this one and the last one in class tomorrow, okay? Thanks for watching. Make sure you've got good notes on your this notes section up here, especially the stuff about the asymptotes. That's pretty new. Other than that, I'll answer questions in class tomorrow. Okay, guys, have a good night.